Understanding the rare earth hypothesis, we take a look back at the previously mentioned Drake equation, which was developed in 1961 by Frank Drake. It aims to estimate the number of communicating civilizations in the Milky Way galaxy. But as we venture deeper into the cosmos, new discoveries and approaches reshape our understanding of this age-old question. The Drake equation multiplies several variables, such as the rate of star formation and the fraction of those stars with planets. While it provides a foundational framework, many of these variables remain uncertain, making it a rough estimate rather than an exact calculation. The variables consisting inside of the Drake equation are n, the number of civilizations in the Milky Way galaxies whose electromagnetic emissions are detectable, r asterisk, the rate of formation of stars suitable for the development of intelligent life, Fp, the fraction of those stars with planetary systems, Ne, the number of planets per solar system with an environment suitable for life, Fl, the fraction of suitable planets on which life actually appears, Fi, the fraction of life-bearing planets on which intelligent life emerges, Fc, the fraction of civilizations that develop a technology that releases detectable signs of their existence into space. And finally, L, the length of time such civilizations release detectable signals into space. Since 1995, when astronomers confirmed the first exoplanet around the star 51 Pegasi b, our understanding of planetary systems has been revolutionized. Using techniques like transit and gravitational wobble detection, astronomers have identified numerous exoplanets. A newer method, verification by multiplicity, helps in identifying multiple planet systems. Current estimates suggest an average of 1.6 planets per star in the Milky Way, yielding roughly 160 billion alien planets, yet only a fraction might have environments suitable for life. Enter Frank and Sullivan's approach, focusing not on how many civilizations exist now, but whether humans are the only technological species that has ever arisen. This perspective introduces an empirical probability of the existence of advanced civilizations, bypassing uncertainties about civilization longevity. Frank and Sullivan proposed the Nast equation, calculated as the product of the total number of stars, the fraction of those stars with planets, and the average number of habitable zone planets. Their archaeological form of the Drake equation is represented as A equals Nast times FBT, where A stands for the number of technological species that has ever existed, and FBT is the possibility of such species arising. The Drake equation also brings in the pessimism line, defined by Frank and Sullivan, indicates the improbability, low likelihood that humans are the only civilization in the universe. If the actual probability of civilization development surpasses this line, other civilizations have likely existed. Their findings suggest that unless the probability of a civilization developing on a habitable planet is less than 1 in 10 billion trillion, human civilization is likely not unique. This implies other intelligent, technologically producing species have probably evolved before us. In the Milky Way, the probability of another technological species evolving is higher if the odds are better than 1 chance in 60 billion. This research offers insight into how other civilizations might have tackled challenges like sustainability and climate change. These insights could provide valuable models for potential human outcomes. Philosophically and scientifically, this study enriches our understanding of existence in the cosmos. It underscores the likelihood that humanity is not the first technological civilization, encouraging exploration into the factors influencing the longevity or decline of civilizations. As we continue to search for the stars, the legacy of the Drake equation, and these new approaches remind us of the infinite possibilities that await discovery in our universe.
Hello, class. My name is Edgar Zambrano, and I am in Stars and Galaxies. My group's topic is the probability of life in the universe, and my topic is SETI. Now, what is SETI? SETI stands for the Search for Extraterrestrial Intelligence and is a scientific effort to detect signs of intelligent life beyond Earth. What is the history of SETI? SETI was founded by a group of visionary scientists and thinkers. The SETI Institute was officially established in 1984 by Tom Pearson and Jill Tarter as a non-profit organization focused on the search for extraterrestrial intelligence. The concept of SETI grew from earlier work by Frank Drake, who conducted the first modern SETI experiment in the 1960s and formulated the Drake equation. The Drake equation is a speculative equation that gives an estimate of the likelihood of discovering intelligent extraterrestrial life in the galaxy. Expressed as a product of a series of variables such as the number of stars, the fraction of stars with planets, the fraction of planets on which life evolves, the average lifetime of a civilization, and so on. This equation allows scientists to estimate the number of civilizations capable of communication in the galaxy. Me again. Here is the equation right there. All right, let's get back to it. SETI uses radio telescopes to detect radio signals from space which may be emitted by extraterrestrial civilizations. SETI also uses optical telescopes to detect optical signals such as laser pulses which also might be used by extraterrestrial life. SETI generates massive amounts of data from observations. Sophisticated software and supercomputers are used to sift through this data and identify potential extraterrestrial signals from the noise of natural sources. SETI uses advanced algorithms and machine learning techniques to analyze vast amounts of data collected by radio and optical telescopes. In addition, SETI also considers other parts of the electromagnetic spectrum, such as infrared, which might reveal evidence of extraterrestrial technology. An example would be detecting heat from a spacecraft. Challenges in SETI. Vast distances between stars can cause challenges of detecting faint signals, signal interference from distinguishing human-made interference and extraterrestrial signals. The Fermi paradox, which highlights the contradiction between the high probability or extraterrestrial life and the lack of evidence or contact. Major projects. Breakthrough Listen is a project to search for intelligent extraterrestrial communication in the universe with $100 million in funding and thousands of hours of dedicated telescope time on state-of-the-art facilities. It is the most comprehensive search for alien communication to date. Breakthrough Listen project. The project began in January 2016 and is expected to continue for 10 years. It is a component of Yuri Milner's Breakthrough Initiatives program. The Breakthrough Listen project is based at Berkeley SETI Research Center. Exoplanet discovery plays a significant role in SETI because finding planets in the habitable zone of their stars increases the likelihood that they could support life, including intelligent life capable of communication. In conclusion, SETI is a vital scientific endeavor aimed at answering one of humanity's most asked questions. Are we alone? By searching for signals from intelligent extraterrestrial civilizations, SETI drives innovation in astronomy, technology, and data analysis. It challenges our understandings of life in the cosmos, sparking curiosity and inspiring future generations. Through this search, we confront the Fermi paradox, exploring why, despite the vast potential for life, we haven't made contact. SETI offers profound philosophical insights, urging us to reconsider our place in the universe and shaping the future of space exploration and human discovery. And then here are my sources.
name is Will Motomura, and I'm in Group 9, presenting the Fermi Paradox. So, the Fermi Paradox can be explained simply in 3 words. Where is everyone? The universe is seemingly infinitely large, and hundreds of billions of galaxies, each containing hundreds of billions of stars in it. And yet we haven't had a single sign of extraterrestrial life. This contradiction of the high likelihood of but the lack of contact with aliens is what we call the Fermi Paradox, developed by Italian physicist Enrico Fermi, who asked that question, where is everyone? Although the answer to this question remains unsolved, there are numerous theories surrounding the paradox that potentially answer this impossible mystery. One of these theories is the dark forest hypothesis. Imagine being in a silent dark forest, and you suddenly come across another creature or human. You have no idea what their intentions are, and the safest course of action would be to eliminate them without taking risks. In this analogy, the universe is the dark forest, and perhaps the aliens reason that the safest thing to do is to avoid interaction with other civilizations, including us. Let's take a look at another popular theory called the Great Filter Theory. This theory proposes the idea of a filter, or a step in the civilization's process of evolution that most fail to cross. There are 2 possibilities within this theory. Either humans have already overcome this filter, or the filter is still ahead of us. The filter could be as simple as the development of life, or it could be as catastrophic as the destruction of civilization, like nuclear warfare. The rare Earth hypothesis is a theory that states that perhaps the conditions of Earth forming and developing intelligent life was extremely rare and coincidental. Maybe some of the required conditions and events leading up to where we are now are almost too specific, and that the probability of other civilizations similar to us forming it is extremely unlikely. Some of these examples, some of the conditions, are like the stability of our sun, or the positioning of Earth in the Goldilocks zone, or the presence of our moon. The last hypothesis we're going to look at today is the zoo hypothesis. The zoo hypothesis states that perhaps the higher life forms of extraterrestrial species are deliberately avoiding interference to contact to observe Earth in order to allow us to develop naturally. Whether it be through means of hiding their presence through technology or dimensions we cannot comprehend, or observing from extreme distance, aliens may be treating us as if we were zoo animals. There are so many more theories that propose a potential explanation to the Fermi paradox. Maybe our means of technology are so primitive to aliens that perhaps they can't reach our signal. Or maybe it's the opposite, and our technology is so much more advanced than any other civilization. It's kind of like trying to receive a Morse code signal from your phone. Maybe every civilization inevitably destroys themselves once they reach a certain point through war or resource exhaustion. Maybe alien civilizations have already come and gone before humans ever came to be. Or maybe other civilizations are simply incredibly far away from us, and we've simply have not had the time yet to reach those distances. Whatever the answer may be, the Fermi paradox is an unsolved mystery, and will likely remain so for a very long time, until humans can reliably establish a means of interstellar or perhaps intergalactic travel.